Hi guys. This lesson is going to discuss quadratics and the different parts about quadratics. So if you notice, we've got some vocabulary words on the outside here that we're going to look at. And in order to make this foldable, it's a little different than the foldables we've done in the past. You don't just fold it in half. What you're going to do is you're going to take one side and you're going to fold it so it lines up with that y-axis in the middle. Crease it, and then you're going to take the other side and do the same thing so that it folds up with that y-axis in the middle, and crease it. And so that should get you your nice cute little foldable. And you're going to take some scissors, and since this is a vocabulary foldable, it's really important that you cut it, guys. We don't want to just leave it open, so we have to open the whole side. We want to be able to just lift a flap and actually look at the vocabulary words, so please cut it. Take the time right now to cut it just like I'm doing. Okay? Alright. And the next thing we're going to do is we're going to make sure that we open it up. And here is the function. And this is called a quadratic because it has x squared. So this is different than what we're used to. Normally we have linear functions. And this time we're going to be dealing with quadratics. The standard form for quadratics is ax squared plus bx plus c. That's standard form for quadratics. So for this equation here, we have a, b, and c. A is hiding before this x squared as a 1. B is a 2. And c is a negative 8. Okay? Alright. In order to continue on with this, we need to graph this function. So please take out your calculators. And what you'll do is you'll turn it on. You're going to go to y equals on your calculator. That's right here where my finger is pointing. So push y equals. And if anything is typed right here, you're going to push clear. And then you're going to go ahead and type in your equation. You don't have to put the 1. So you're going to push x and then the squared button, which is right here where my pen is pointing, or my finger is pointing right here, x squared. That makes a little squared on there. And then you're going to say plus 2x minus 8. Now you could push graph if you would like, but you don't always get a good graph. And if it doesn't show up as a regular graph, you can go to zoom, and then you can push 6. That'll get you your standard graph. But the problem with this is you can't tell the actual points, so I want you to go to the table. So go to second and then table. And here it lists out all of the ordered pairs. So we can just start here by looking at 1, and it says 1 is at negative 5. So we're going to go 1, negative 5 and put a dot. And then 2 and 0 and put a dot. And then 3 and 7 and put a dot. And then 4, okay, I can't do 4 and 16, it's too much for the graph. But this isn't all of my graph, because remember when we pushed go here, see how we see half of our graph already? How do we get the rest of the points? Well, if you go back to your table, you can arrow up and you can see the rest of the points. So we have negative 1 is at negative 9. Oh, hold on. We got 0 is at negative 8. And then negative 1 is at negative 9. And then negative 2 is at negative 8. And then negative 3 is at negative 5. Negative 4 is at 0. And negative 5 is at 7. Okay. Alright. So when you do that, when you're finished, if you notice the graph actually has a pretty smooth line. When we push graph, that's what it's supposed to look like. So we have our exact points graphed on there, and now we're going to draw that pretty smooth curve through our graph. Okay, And we're going to put arrows up here at the end because it keeps going, right? We just couldn't graph them on our graph because we couldn't really see. So there's our graph. Now, did you notice when you were graphing that there were points that repeated? And that's because we have something called the axis of symmetry, okay? On this graph, the axis of symmetry is in the middle, and it's going to be the same for every single graph, okay? So that axis of symmetry on this graph, the middle of the graph, that's right here, okay? This is called the axis of symmetry. Axis of symmetry. Okay, and the axis of symmetry is the line that cuts the graph in half. Okay, axis of symmetry is the line that cuts the graph in half. So this right here, this is our axis of symmetry. I might draw a picture on the front just so I have an image. And our axis of symmetry, remember, is the line, the straight up and down line that cuts the graph in half. Okay. Alright, so let's put that definition on the inside. The line that cuts the graph in half. Okay, and that line is always x equals, in this case it's x equals -1. Okay, there's a formula for it. Let's go ahead and write it down. It's x equals -b over 2a. And you're going to use this information over here, like the a, b, and c that we're talking about. You'll use it to figure out that axis of symmetry, but for today that doesn't matter. Okay, but you'll need to use this for later on, so that's why we're putting it on there. Okay, the next thing that we can notice about this graph is maybe something you've heard of before, and that's going to be the y-intercept. So that's this one right here. And the y-intercept is where it crosses the y-axis. Okay, where the graph crosses the y-axis. So I'm going to use my green highlighter, and I'm going to highlight the y-intercept and label it on my graph. This is the y-intercept. Okay, and that y-intercept on this specific graph is at 0, -8. Okay, so the y-intercept. Alright, let's skip domain and range for just a second. We'll do those together at the end. And now let's talk about the vertex. Okay, the vertex is the maximum or the minimum point on the graph. So if I have a graph that faces up like this, the vertex is going to be my minimum. And if I have a graph that faces downward like this, the vertex is going to be my maximum point. Okay? And remember, this one we're thinking is positive because it's a happy face. And this one we're thinking is negative because we could make a sad face with it. Okay? Smile, frown. Okay? Alright, so on our graph, our vertex is going to be down here at the bottom. I'm going to color that one orange. So my vertex is right here. Vertex. Okay. And inside we're going to say the vertex is the highest or lowest point of the graph. The vertex is the highest or the lowest point of the graph. Okay, so on my graph here, the vertex is at -1, -9. Okay. Alright, the next vocabulary word we're going to look at is x-intercepts, roots, zeros, and solutions. So when we're talking about quadratics, for some reason they decided that instead of just calling it x-intercepts, we're going to call it all these different names. these all mean exactly the same thing. So there's 1, 2, 3, 4 different ways to say where does it cross the x-axis. Okay, there's 4 different ways to say this is where it crosses the x-axis. So on this specific problem, this graph has 2 x-intercepts. It has one here, and it also has one here. Okay, but it can have 2 x-intercepts, or it could have 1 x-intercept, or it could have no x-intercepts. It could never cross the x-axis. So there's multiple different ways that we could have a solution on these types of problems, okay? But in this specific case, we have -4, 0 and 2, 0. So in this case, we have 2 solutions. We have 2 x-intercepts. So 2 solutions. So the most you could possibly have are 2 solutions, or 2 x-intercepts. Alright, the last thing we need to talk about is domain and range. So remember, the domain is the set of all of the x values. Okay, it's all the x values. Remember, we take our pencil and we look on either side, the left and right side. On the left side, it has an arrow. On the right side, it touches an arrow. So what do we call it if it touches 2 arrows? We call it all real numbers. Okay, and that's because if I drew my boundaries on the left and the right, both are touching arrows. Okay, for quadratics, it's always going to have a domain of all real numbers because it always has 2 arrows going in both directions. Now remember, for range, my range is going to be a list of all the y values. So in this case, I have a graph that goes like this. So I have a line on the bottom and a line on the top. The top is touching arrows. What number is this bottom touching? Well, in this case, the bottom is touching -9 right here on the graph, right? And so it's getting bigger, it's getting higher than that -9. So we say y is greater than or equal to, because it was a closed dot, -9. Okay? For for range, we're either going to be getting bigger because the graph is facing up like a smile, or we're going to be getting smaller because the graph is facing down like a frown. Okay? So if the graph is getting bigger, we say that it's greater than, and if the graph is getting smaller, then we say it's less than. Okay? Thanks for watching. Have a wonderful day.